I sent 2 requests to the same AI agent, the same endpoint, doing similar work. One took 10 seconds with 10 operations. The other took over a minute with 42 operations. The same agent, completely different outcomes. That is the problem with agentic systems. The LLM decides the path. It chooses which tool to call, how many times to loop, and what data to fetch. Every request can fan out differently. You cannot predict it. You cannot predict it. And if you cannot see what's happening, you cannot debug it. You cannot optimize it. And you cannot trust it. But here's the good news. We already solved this problem for distributed systems. OpenTelemetry tracing. And it works for AI agents as well. Building agents is an exercise in taming uncertainty. We want to make them as flexible as possible, yet we don't want to lose control. So, how do we know what AI is thinking and how it arrives at the outputs we see? The short answer is, we don't. No one truly knows what's happening inside LLMs. They're black boxes. They're unknown. However, we can know which interactions are happening between users, agents, LLMs, and tools. We might not see inside the box, but we can see everything going in and out of it. Now, the problem is that when we create an AI agent, we cannot know in advance what will happen. We don't know what users will ask for. We don't know which context will be sent to LLMs. We don't know which tools the LLM will request the agent to execute. We don't know what the answers will be. Every interaction is potentially unique. So, how can we improve agents if we don't know what's going on? One answer is evals, evaluations. Evals are systematic tests that measure how well your AI system performs. They can check whether the model gives correct answers and doesn't hallucinate. But they go beyond just LLM outputs. Evals can test whether your agent chooses the right tools, follows the correct sequence of actions, and produces the expected end-to-end results. So think of them as tests for AI behavior across the entire stack. But, and this is important, evals alone aren't enough. It's the same distinction we have in traditional software. Tests check expected behavior in controlled conditions, while production observability shows what's actually happening with real users and real data. You need both. Evals catch problems you can anticipate, but what about the problems you never thought to test for? That's where observability comes in, and we already have technology for this in traditional systems. Think about how we handle this outside of AI. How do we know that our distributed systems work correctly? How do we figure out what's happening when a request comes into the system? So let's say a request comes in from a user and hits the frontend. The frontend calls a backend service. That backend needs data, so it calls another service, which calls another, which fans out to multiple services. What looks like a simple request from a user is actually very complex, especially in larger systems. So we need to know what's happening inside each of those services, but also where the request travels. All the way until the final response is sent back. And just like with AI agents, the trajectory of those requests cannot always be predicted in advance. And that, ladies and gentlemen, boys and girls, that's where OpenTelemetry comes in, specifically tracing. Now, I will not go deep into OpenTelemetry basics here since I already published a few videos. They're somewhere over there. The short version is OpenTelemetry is a CNCF project that provides a vendor-neutral standard for collecting telemetry data. Tracing captures the journey of a request through a distributed system. Each operation becomes a span with timing, status, and context. Spans link together into a trace, showing the complete request path. Now, let's get back to AI agents. The problem is fundamentally the same as with traditional distributed system. A user request comes in, gets processed by the agent, which sends prompts to an LLM, receives responses, maybe calls some tools, we don't know, maybe it connects to external services through MCP, we don't know, and eventually it returns a result. It's a distributed system with unpredictable paths. Now, there are purpose-built tools for AI observability, LangSmith is probably the most popular right now, especially if you're using LangChain. LangFuse is a solid open source alternative. These tools work well and they're widely adopted. But here's the thing. If you already have OpenTelemetry in your infrastructure, do you really want your AI observability siloed into a separate tool? Wouldn't it be better to see your agent traces alongside your API traces, your database traces, your message queues traces, all of that in one place? Luckily for us, the OpenTelemetry community recognized this and created semantic conventions specifically for generative AI. These are the gen_AI attributes that standardize how we capture AI-specific telemetry. They track things like which model you're using, what parameters were sent, how many tokens were consumed, why the model stopped generating, and what tools were called. It's vendor neutral, so whether you're using OpenAI, Anthropic, Azure, or Bedrock, the telemetry looks the same, and it plugs into the observability backends you're already using. Here's an example of a typical AI agent interaction and how it looks like. A user sends a request to an agent. The agent sends a prompt to the LLM. The LLM might decide it needs more information, so it requests a tool call. The agent executes local tools, calls MCP servers for traditional capabilities, or delegates to other agents through A2A. Those tools and MCP servers can call APIs, run terminal commands, or query databases. Results flow back to the LLM, and this loop repeats until the LLM has enough information to respond. A single user request can fan out into dozens of LLM calls, tool executions, agent delegations, and external system calls. Every one of those interactions needs to be traced if you want to understand what's actually happening. And that is exactly why OpenTelemetry makes sense for AI agents. It's not just about tracing the agent itself. When your agent calls an API, that API is probably already instrumented with OTel. When it queries a database, that database call already has a span. When it hits a message queue, you already have traces for that. By using OTel for your agent, you connect the AI traces to everything else. You get one unified view: the user request, the agent processing, the LLM calls, the tool executions, and all the downstream services they touch. That is the real power over there. Now let me show you how this looks like in practice. I have an AI agent running in a Kubernetes cluster with OpenTelemetry instrumentation sending traces to Jaeger. Let's interact with it and see what we can observe. I'm going to ask the agent to query, let's say, what's running in the cluster. And it works for a while, and then we get the output. Now, let me ask it something else. So, I made 2 requests to the same agent, the exact same endpoint. Now, let's see what actually happened under the hood. Over here, we can see 2 traces from those requests. One has 42 spans and took over a minute. The other has 10 spans and finished in under 10 seconds. Same agent, same endpoint, widely different behavior. Now, if we drill into the larger trace, we can see every operation: kube control API calls, quadrant collection queries, embedding operations, vector searches, and plenty more. Each one captured as a span with timing and context. This is the nature of agentic systems. The agent decides which tools to use, how many times to loop, what data to fetch. Every request can fan out into a completely different set of operations. And that's why tracing matters. Without it, you would have no idea why one request took a minute while another took seconds. With OpenTelemetry, you can see exactly what happened. Traditional non-agentic software might benefit from traces, but the flow is still predictable. Agentic workflows are not. The LLM decides the path. That makes tracing even more important. So, here's the question. Why OpenTelemetry over agent-specific tracing tools like LangSmith or LangFuse? And here's the answer. OpenTelemetry or OTel is the standard. All major observability vendors support it. Datadog, New Relic, Dynatrace, Splunk, Grafana, Honeycomb, AWS X-Ray, Azure Monitor, Google Cloud Trace. If your observability tool doesn't support OpenTelemetry, you have bigger problems than agent tracing. More importantly, the rest of your system is likely already instrumented with OTel, databases, APIs, message queues. When your agent interacts with them, you want one unified trace, not silos. Now, agent-specific tools are not useless. They're fine for prompt debugging, A/B testing, evaluation frameworks, cost dashboards. But for tracing, the standard is OTel. And here's a litmus test. If an observability backend doesn't support Gen AI conventions yet, are they likely to support other emerging standards? Probably not. Those vendors are falling behind regardless. And before we close this one, a quick note. The agent you saw in this demo was DevOps AI Toolkit, a project I've been building. It has OTel tracing baked in along with MCP server tools for Kubernetes cloud resources and more. If you found this useful, check it out and give it a star. It helps more than you think. The link is in the description, probably.